Working with large-scale financial models often means waiting seconds, then minutes. High-end servers consume power and burn through budget, while analysts lose focus waiting for results. That delay costs money and leads to suboptimal decisions. Now, imagine an analyst interacting with a billion-row data cube without delay. The green numbers reflect the changes I just made. Values across the entire hierarchy recalculated almost instantly. I'll discard this draft now and enter new data. Notice, every change is committed directly to the database. This isn't a browser-side recalculation. It's a live, synchronous rebuild of the data slice. I'll refresh the page to prove it. Data is persisted and fully consistent. Key detail: this sales cube starts with 1 billion rows, spans 7 dimensions, and has a potential size of over 2 trillion cells. This is a pre-configured view with live formulas. We're using basic calculations here, like unit cost. Changing price or quantity instantly updates the calculated price and rolls up through the hierarchy. My local laptop is running both the back-end database and the front-end interface. Just a 4-core CPU and 8 GB of RAM. The P&L report for sales is generated live from this dataset. In this example, all contract values are in different currencies. Let's see how fast changing the monthly average exchange rate updates the final profit and loss statement. Everything is calculated in real time. I'll now commit the draft changes, merging them into the main model version. Unlike modern OLAP architectures that separate storage and compute, QubesFolder uses a compute pushdown approach, moving calculations directly to the data. All heavy lifting is done by ClickHouse vectorized engine, processing data right at the storage layer. QubesFolder acts as a lightweight translation service with 3 core functions. First, converting multi-dimensional queries into highly optimized SQL. Second, managing logical transactions that guarantee atomicity, consistency, and isolation, regardless of your ClickHouse cluster configuration. And third, handling version control for changes. Built-in versioning lets financial analysts safely edit and revert data across isolated scenario branches. This is a fully functional computational core with a clean architecture, written from scratch with 0 proprietary dependencies. So, 1 billion rows, 7 dimensions, over 2 trillion potential cells, consolidation and hierarchy calculations, under 1 second, live, on a standard laptop. The full demo model specs are linked in the description. So far, this has been a validation of our core algorithm's performance. But development continues. The core is ready. Next up, enterprise-level stress tests. In upcoming videos, we'll validate transaction integrity and isolation under high concurrent load, and implement complex cost allocation scenarios. This is a devlog tracking our journey to a production-ready solution. Follow the progress.